You want to take it now?
Yeah, okay. So moving on to Europa, moving out into the outer solar system. So yeah, I'm just going to let you know what we've been up to on Europa. And next slide. Yay, the global map is in production. It's very exciting. So what are we up to now? Now we are starting to work on some regional mapping at 1 to 2 million. And we're focusing on areas where we can get more than an order of magnitude better in detail. We're not planning these to be SIMs because of the way Europa regional data is sort of scattered across the globe due to the flyby nature of the Galileo mission, the way the data was taken. So there's only about 10% coverage of what we consider regional resolution data, 250 meters per pixel, and these are usually in like postage stamps scattered across the globe. So for this region, we're not looking to do SIMs, they're not topical maps, they're not able to be quadrangles, but instead our goal is to sort of lay the framework for regional mapping on Europa so that in the future when the Europa Clipper data set comes back, which will have full Europa or full coverage at the regional scale, there will already be this framework for what to do and how to produce quadrangles at a regional resolution. And the main point that I want to drive home here is that we can still make a set of regional maps that have consistent units and scale. And the power from this comes from laying them into the new global map because it allows for identification of cross-cutting relationships that link the disparate regions. And I'll show you that in a little bit. But other than that, we're also looking forward to the new USGS base map of Europa, which will be coming out hopefully around the end of the year. And next slide. So here's the global map in case you have missed the past couple of the USGS Mappers meetings, but this is the final version of the map. The only thing that should be changing are some of the symbology will change for publication. I want to take this opportunity to thank everyone who's helped throughout this process, especially Alex Patoff and Dave Sensky, who are part of our mapping team, our reviewers throughout this process, and also everyone at the USGS for their support and advice and help, especially Jim Skinner and Corey Fortezzo. Next slide. But like I said, today we'll mostly be talking about the regional maps that we've been working on. So here we're going to focus on that little black box area called Kanamara Chaos. Next slide. So this is the current state of the Kanamara regional map. So this is a 1 to 2 million. And you can see there are a variety of units identified. We have about 4 or so different chaos units in shades of green. The pink and purple are different band morphologies. The blues are different subdivisions of the regional planes. And we also have a variety of linear features identified. And next slide. An easier way to kind of look at this, though, is comparing it to the global map. So on the left, you have the global map at 1 to 15 million, and on the right, you have our new regional map at 1 to 2 million. Again, we're talking an order of magnitude of more detail. And you can see how the units get subdivided from the global map to the regional map and how much more detail we're able to provide. So for instance, that one chaos unit in green on the global map is now subdivided into 4 different chaos units at the regional level. And we have different morphologies of linear features that are able to be identified. In the global map on the left, you just see black lines because they were not able, the morphology of those linear features is not able to be identified at that scale. But at the regional scale, we can identify different morphologies such as ridged or smooth or different sorts of things like that. And then also we are able to subdivide that background terrain, what we call regional planes, and the global map on the left, that light blue, becomes a couple different units in the regional map on the right. And so we're able to dig deeper into that underlying unit that's behind everything in the global map. Next slide. So you can also look at this in a slightly different way. Here what I've done is just kind of spiderwebbed out how we've subdivided the units from the global map on the left to the regional map on the right. And you can see that we're adding a lot more detail, but not only adding detail, we're identifying what really makes up regional planes at the global scale, what really makes that up at the regional scale. And so it's sort of interesting. Next slide. again, the main point I want to drive home here is that in addition to providing a more detailed morphology, the power of making these sim-like regional maps now, even though we don't have the data to make quadrangles or anything like that, is that we can inlay the disparate regions onto the new global map and provide relative age information that links the different regions. So here you're looking at one regional map that we've made on the left and a portion of a regional map on the right. And you can see in the yellow circle that these have linear features that are connected, or that where the age relationship is defined in the global map, where band 1 is younger than band 2. And so we're going to be able to relate the relative ages of the features in the region on the left with the region on the right, which will be really powerful. And that's what we've been doing on Europa. So thanks, and I'll take any questions. Or I guess at the end, I'll take questions.